what separates quantum mechanics from the classical physics. Now we talk about why there is a division between classical physics, this side, and quantum mechanics. What is new in this science? The most prominent characteristic of the classical physics is deterministic world, that is, time and space or motion follow an equation, so we can exactly tell when and where the mass is or particle is. Whatever the behavior of the nature is very deterministic. That means it's exactly the way our equation tells us. Now quantum world, it's non-deterministic world. Why is that? Time and space are digitized and probabilistic. That means the digitized value, which value it takes, it's function of probability. So this is totally different world we're dealing with. So say a deterministic world, if you extend the time, we can predict the future. So it's a predictability. This is very important for engineering, because if you cannot predict what's happened, airplane fly and it's gonna land. If you cannot predict that, then engineering fail. Prediction gives a tremendous benefit to the humanity, and this was a pillar of science in the classical physics. And if we reverse time, we can go back to the past. That means you take the equation t and we reverse the time. We know exactly where it's come from, right? And there's an argument about whether we can reverse the time or not. The entropy increases all the time, so time is one directional. But entropy increases only in an isolated thermal system. If we give energy, entropy can decrease and time can be reversed. So deterministic world, the time, the function is the behavior of the physics world is a function of t, and t can go positive side or negative side, and there's no distinction between them. Okay? But non-deterministic world, probability dictated. This is a quantum world. What happens is, even if you extend time, we cannot predict the future, because future is unpredictable. This traumatized and paralyzed science and engineering. When it's beginning it came out, a lot of scientists reject the idea. How come you cannot predict? How can you do engineering if you cannot even predict what's going to happen, right? The Einstein coined the famous term, God doesn't play dice. That means it has to be predictable, and you cannot depend on probability in a science. Okay. Every measurement at the quantum level is probabilistic. Probability is characteristic of nature. So there are a lot of argument in 19th century whether this can be accepted as a science or not. Okay, and Einstein hated the idea of quantum mechanics using probability, but it seemed like that's the way it is. Even if you reverse the time, no guarantee to go back to where we are. We cannot tell where it's come from because it's based on probability. So time direction at the quantum level. Another things we found out is probably time may be going backwards sometimes. the time is not always going forward. So we need a different way to understand time and generally nature. Classical physics doesn't provide that. So that's why there is a big division between classical physics and quantum mechanics. So, question is, does non-deterministic science conflict with deterministic classical physics? Answer is no. Why is that? Well, we're talking about particle, very tiny particle world. But if you take statistical average, and that's what classical physics is. So when we take at our human size and make a science based on that size, it's perfectly fine. Classical physics is fine. And why it doesn't conflict? Because it's average of many particles' behavior. Okay, but if you take individual particle, then it doesn't behave like classical physics. So they don't conflict. They are just simply result of statistical average. Next question is, quantum mechanics is probabilistic because we do not understand the nature very well? Well, actually it's not. I tell you why. Right now the consensus in the science world is the nature is probabilistic. It's not because we don't understand the behavior. You know, sometimes you flip the coin, you don't know which way is head or tail. We don't know, so we use probability. So probability is an escape for the things we don't understand. And that's not because quantum mechanics we don't understand, we're using probability. Actually, it's the characteristic of nature. And the few evidence I present here, quantum state is digitized. Okay, now digitized is light is polarized vertical or horizontal, and when you tilt the polarization filter at 45 degree, then what's happened? There's no such a thing. So 45 degree polarized, either polarized vertical or horizontal. Now what's happened is when you observe photon going through such a filter, tilted filter, you get sometimes horizontal, sometimes vertical. It's digitized, so you have to take either one, vertical or horizontal. But in the world of the physics, you can tilt only 45 degree. So what's happened is you get photons sometimes vertical, sometimes horizontal. It's become 50-50 chance. Okay, so that's one of evidence. Another evidence is like a tunnel effect. Say you have a potential well, and you confine the particle. In the classical physics, the particle energy is lower than potential well. It's confined there forever. It's never escape unless you give energy, stimulus energy. But even without giving any additional energy, sometimes it's go through that potential well and escape. Why? It's just a matter of chance. Some probability exists that it's passed through the potential well. Okay, this is against our norm of understanding and physics. Okay, so this is another evidence that nature is probabilistic. Okay, so difference between mass probability and quantum mechanics we need to understand. Suppose criminal is hiding somewhere in the neighbor, and maybe he is hiding in the house or car, and we don't know, so we say 50-50 chance he's in the car or house. So this probability is, we apply for probability because we don't know. And if you open both door, car's door and house door, here you go, we find the criminal here. Okay? But particle, it can be 50% chance in one state and 50% state another chance. Okay, we don't know, maybe 50% 1, 50% 0, but when we open the door on the both side, here you go, just like a criminal, we find it. The difference is we close the door again and open again. Then next time you may have particle on the other side. Okay, here in the criminal, you close the door and open again. Criminal doesn't move to here, it's still there. So you close and open the door, no matter how many times you repeat here, criminal is on one side. It's fixed, deterministic. But particle, when you open the door, you see particle on this side. You close again and open again, then you see particle here. So until you open the door, you don't know where the particle is. That's the quantum mechanics probability. It's not like probability that we use because we don't know where it is. It's not the probability for deterministic world, it's a probability for non-deterministic world. We don't know which way it goes until we open the door. That's the quantum world. So the speculation is a particle is maybe moving between them very fast. Every time you open, that's the moment you see the particle. Say particle going to the bathroom and bedroom and moving back and forth. We open the door, bathroom and bedroom, then we find a particle at that moment. So in order to avoid that situation, we did a test. We opened the door at the same time exactly, and what's happened? There's no way particle can move from one to another because the speed is bounded by light speed, and we don't give even the time to move at light speed. They still behave like that. That means, you know, it's not moving faster than light speed. It could be moving faster than light speed. Okay, that's the recent discovery on the quantum mechanics. Sometimes particles has characteristic that it's move faster than light speed. So its quantum mechanics is still evolving. For example, quantum entanglement speed is just discovered by China. Entangle speed seem to be faster than light speed. Okay, so that means maybe something moving back and forth faster than light speed, and you open the door. It's happened to be here, not here. Then you see this. Next time you open, then it's move again. Maybe the particles moving so fast that we cannot catch it. Okay, so quantum mechanics still evolving, with still gaining more understanding, but definitely it's different from classical physics. Okay, so I hope you enjoyed this videos. Please check other videos, and if you like, click subscribe.